Page 16. Draw a dashed line y equals x and determine if the two equations graphed are inverse functions of one another. Let's look at this one. The first thing you want to do is draw the line y equals x as a dashed line. They are symmetrical, it looks like. However, they're not inverse functions of each other because the red one is not a function. So the red graph is not a function. Let's look at the next one. So we draw our line, and they look symmetrical, and they're also both functions. So we could just put yes. And then let's look at this one right here. I believe that one was also on the notes. That one is a yes. Solve for x. Y will be in your answers. We have y equals 2x minus 7. To get x by itself, let's add 7 to each side. Y plus 7 equals 2x. Divide each side by 2. And then we have x equals y plus 7 all over 2. Try the next one. Pause the video and try that next one. Let's look at this one. Y equals 3 square root x plus 9. To get x by itself, we can first subtract 9 from each side. We have y minus 9 equals 3 square root x. Divide each side by 3. We have y minus 9 over 3 equals square root of x. To get rid of a square, we exponentiate each side by 2. So then we have y minus 9 over 3 squared equals x. Pause the video and try the next one. Y equals 7 square root x minus 6. Let's look at this one. Y equals 4 times the cube root of x plus 1 plus 2. To get x by itself, we first will isolate the radical. Y minus 2 equals 4 times the cube root of x plus 1. To get the radical isolated, we're going to divide each side by 4. Y minus 2 over 4 equals the cube root of x plus 1. To get rid of a cube root, we will cube each side. So exponentiate each side by 3. We have y minus 2 over 4 cubed equals x plus 1. Subtract 1 from each side. And then you have y minus 2 over 4 cubed minus 1 equals x. Pause the video, try the next one. Y equals 2 times the cube root of x minus 1 plus 5. Let's look at this one. Y equals x cubed plus 4. Subtract 4 from each side. Y minus 4 equals x cubed. To get rid of a cube, we exponentiate each side by that reciprocal, 1/3. The 1/3 power is the same thing as the cube root. So the cube root of y minus 4 equals x. Try that last one on this page. Y equals x minus 7 cubed. Page 17. Find the inverse algebraically. Specify the domain and range of the inverse. Let y equal f of x and x equal f of negative 1 of x. I was talking about the original functions. So we have y equals 4 times the square root of x minus 2. Let's switch the x and the y and solve for the y again. We want to divide by 4 each side. X divided by 4 equals the square root of y minus 2. To get rid of a square root, we'll exponentiate each side by 2. X over 4 squared equals y minus 2. Add 2 to each side. So then we have f inverse of x equals x over 4 squared plus 2. The domain of this function will be from 0 to infinity. Why is it not all real numbers? It's because the original function did not contain all real numbers. So this is a restricted domain here. And then your range is still the same, 2 to infinity. Pause the video and try the next one. Y equals 5 times the square root of x plus 1. Let's look at the next one here. Y equals 1/2 times the cube root of x plus 3. So let's switch x and y and solve for the new y. So we're going to subtract 3 from each side. X minus 3 equals 1/2 cube root of y. Divide each side by 1/2, which is the same thing as multiplying by 2. So then we have 2 parentheses x minus 3 equals the cube root of y. To get rid of a cube root, we'll exponentiate each side by 3. So then we have f inverse of x equals 2 parentheses x minus 3 to the third power. For cube root functions and cubic functions, the domain and range are both all real numbers, negative infinity to positive infinity. Try the next one. Y equals 2 times the cube root of x minus 5. Let's look at this one. Y equals x squared plus 5. So let's switch the x and the y and solve for our new y. Subtract 5. X minus 5 equals y squared. Take the square root of each side. It's the positive part of the domain, so it's just going to be a plus square root of x minus 5. So then we have f inverse of x equals the square root of x minus 5. The domain would be from 5 to infinity, with 5 being included and infinity excluded. And then the range will be from 0 to infinity. Try the next one. Y equals x squared minus 5. To do this one, switch the x and the y and solve for the new y. X plus 5 equals y squared. Take the square root of each side. This is only the negative part of the domain, so we're going to put a negative sign in front. So f inverse of x equals negative square root of x plus 5. The domain would be from negative 5 to infinity. The range will be from negative infinity to 0. If you were to graph this one, it would look like that. If you were to graph the previous one, it would look like this. Y equals negative x minus 4 squared. We have a restricted domain of 4 to infinity. So that means that our range of this one is going to be from 4 to infinity. To solve for the new y, we'll first divide each side by -1, and then we want to get rid of that squared, so we're going to take the square root of each side. The restricted domain is the positive part, so we're going to put a plus sign right there. So we have the square root of -x equals y minus 4. Add 4 to each side, and then you have your inverse f inverse of x equals the square root of -x plus 4. The domain of this would be from negative infinity to 0. Your h value here in the inverse function is 0. Try the next one. Let's do one more on this page. Y equals x plus 1 squared minus 9. It has a restricted domain of negative infinity to -1. Switch x and y and solve for the new y. Add 9 to each side. So we have x plus 9 equals y plus 1 squared. To get rid of the square, take the square root of each side. You're going to put a negative sign in front of that. So we have negative square root of x plus 9 equals y plus 1. Subtract 1 from each side. We don't subtract 9 minus 1. The 1 just goes on the outside. So we have f inverse of x equals negative square root of x plus 9 minus 1. The range is going to be your restricted domain of the original. And then your domain is going to be from -9 to infinity. Try the last one on this page. The reason why we use restricted domains is so that the inverse will be a function and not just a relation.